guys, what's up? It's Miss DeAngelis here to talk all about the Bohr model diagram. This was designed by Alfred Bohr. And as you know, we use models to demonstrate things that are either really large like the universe, or they're going to be really on a small scale, things that we can't see with our naked eye. So let's explore the atom according to Mr. Bohr, Mr. Alfred Bohr. Okay, let's get into it here. I'm going to get my pen set up so that I can write on the screen, and let's go. Okay, so let's look first at the element of boron. The element of boron has an atomic number, and this is really important, atomic number of 5. And as I've told you before, protons have to equal neutrons. And that's because an element has to have a charge of 0. So the charge has to be 0. So in order for that to happen, we have to have protons, which are positive, and we have to have the same number of electrons. And in this case, that number is going to be 5, so that we have 5 positive and we have 5 negative, and as a result, we're going to end up with a charge of 0. Okay, so that's good. All right, so keep 5 in mind, because again, the atomic number tells you the number of protons and the number of electrons. Let's go to this number. This is known as our atomic mass. Okay, atomic mass is the sum of the protons and the neutrons. So again, to review the charges, we know protons are positive, electrons are negative, and neutrons are neutral. The relative mass for a proton is, let's see, a proton's mass is going to be about 1 AMU, and the neutron mass is, about 1 AMU as well. So one of the things we do in math, in science in 8th grade, is we need to round this up to 11, because 10.81, it's kind of a harder number to quantify just in your head if you're doing addition or subtraction. So I think the best thing for us to do is just round this up to 11. That's perfectly acceptable, so don't worry, you can do that on the STAR exam. But anyway, we know that we have a mass of 11. But we don't know how many neutron. We know we have 5 proton, we know we have 5 electron, but how do we know how many neutron we have? The way you figure that out is you say, I have 11 AMU, and I'm going to subtract my 5 protons, and it's going to leave me with 6 neutron. Okay, so again, it's 11 minus 5 equals 6. Think of it this way. I've given you 11 cookies. You know that 5 of them are Oreos, but how many chocolate chip cookies do you have left? So a simple basic math problem, but it's not that obvious where the neutrons are actually found on the periodic table. So you got to do some very simple basic math to get to that point. Okay, so how does this relate to the Bohr model itself? So we know that we have 5 protons, 6 neutrons, and 5 electrons. Okay, draw the number of circles around the nucleus to match the number of energy levels. But wait a minute, Ms. DeAngelis, what is an energy level? Well, let's get into that. An energy level describes where the electrons are actually hanging out around the nucleus. So in this case, we have 2 energy levels. And the reason why we have 2 energy levels is because we have a total of 5 electrons. Now to get into it, keep that 5 in mind for 1 second. To get into it, the first energy level can only have 2 electrons on it. So this is our first energy level. It's the closest to the nucleus. And this is our second energy level. And then if we had to add more electrons, we would be adding a third. And when you get up to high school, you'll be doing subatomic levels, and you'll be, like for example, Copernicum has 112 electrons. So you're going to need more than 3 energy level rings in your drawing to go around the nucleus. So what you need to know too is that we fill the inner rings first. So the inner rings get filled first. So if we know we have 5 electrons, let's move on to the next slide. We know that we have 5 electrons. We're going to do our proton. In the nucleus, I always put the information I know. N equals 6. And out here, just to remind myself that my electrons don't end up in my nucleus, I'm going to put my electrons out here. Okay, that's the symbol for electrons. So I know on the first energy level, I have to put 2. So there they are, 1, 2. I have 3 left. Where am I going to put them? Well, there's no more room on the first energy level, and this is true of all atoms, that electrons only on the first energy level have 2 electrons. And so let's move on to the second energy level where we need to put 3. 1, 2, 3. Okay, so let's add them up. 1, 2, 3, 4, 5. 5 electrons, 5 proton. So I know if I have 5 positive and 5 negative, I'm at 0. Okay, so if we go to the next slide, it'll show you 1, 2, 3, 4, 5. We did it. That's a Bohr model. So moving on, the outer energy level has valence electrons. So these electrons right here are known as your valence electrons. They are in the outermost energy level. So if I had a third ring going around here and all this second shell was filled with 8, the electrons on the third ring would actually be considered the valence electrons. And those are the ones that are going to react with other atoms of other elements. And that's how our chemical reactions occur. So move on, let's practice. So we know that the 4 represents the atomic number. Okay, and by atomic number, we know that protons equal electrons, and we know we have 4 protons, so therefore we have to have 4 electrons. Look at this number here. This is number 9. Let's just leave it at 9 for now. We're going to call this the atomic mass. The atomic mass, as we know, are the protons plus the neutrons. Now, let's go back to the cookies. I have 9 cookies. I know 4 of them are Oreos. How many chocolate chips do I have? So I'm going to say 9, and I'm going to subtract my 4 proton. Okay, and that's going to leave me with 5 neutron. So I can fill in my little chart here. I know that I have 4 proton. I know that I have 4 electron, and I know that for neutrons, I have 5. So does 4 plus 5 equal 9? Yes. Do I have 4 positive and 4 negative? Yes. Okay, so let me go over here, and I'm going to put P equals 4, and I'm going to put N equals 5, and I'm going to put my only 2. Remember, the first energy shell only has 2 electrons, and then I'm going to add my other 2. I could have put it here, I could have put it there. So that's how you would do the Bohr model for beryllium. Now moving on, let's go to nitrogen. Nitrogen, let's see, we've got 7 for the atomic number, 14 for the atomic mass. So just write atomic number, and this is where protons equal electrons. And I know I have 7, so down here I can go 7 plus, and I can go 7 minus with that. And then for nitrogen, I know I have 14 for my mass, and I'm going to subtract my protons, and I'm going to end up with 7 neutron. Neutrons are neutral, so I'm going to add that little 0 there just to remind me that it is 0 charge. So 7. So pretty simple. Everything is 7. So again, P equals 7, N equals 7. I'm going to put 2 on my first energy level, and then I'm going to add the other 5. So 1, 2, 3, 4, and I'm going to pair up the 5th one with the one on top. And that's what you do. Usually your on these outer energy levels that can hold more than 2, you would actually pair them up as you go. So that is the atomic Bohr model for nitrogen. Sodium. Couple things here. We know 11 is the atomic number. Okay, we know that atomic number equals protons must equal electrons. Okay, so that number is going to be 11. So I'm going to put down here, I'm going to put 11 plus and 11 minus, because this way they'll cancel themselves out and it's 0. For the neutrons, check out the atomic mass. It's 22.99. For simplicity, let's just round that up to 23 AMU. Okay, so our mass is 23. This is the atomic unit or atomic mass. Let's just go with atomic mass. And for, let's say 23, and we're going to subtract 11 proton, and that is going to leave us with 12 neutron. So there we go, 12. Sorry, 12. So here we go, P equals 11, N equals 12, and our electrons equal 11. So we know on the first energy level, we add 2. On the second energy level, we can hold up to 8. So, but we know that we have to go to 11. So now we need to add 9 more. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. Did I get there? Well, hold on. I know I put 2 on the first one, and then I put 8 on the second energy level. But I need 1 more in order for all of my electrons to equal 11. So I've got to jump to the third energy level. And I'm going to put one way out there at the top. This now becomes the valence electron. The valence electron, again, is the electron that's out on the outermost level or outermost shell of the atom, and it's the one that's going to be the most reactive. It's going to react with other atoms from other elements, and that's where you're going to have your chemical reactions. That's where that's going to occur. Finally, let's deal with aluminum. So aluminum has an atomic number of 13, so we know that protons are going to equal electrons. In this case, it's 13, so we're going to have 13 proton, we're going to have 13 electron, because we know that 13 positive and 13 negative is going to get us to a 0 charge. Therefore, it's an atom that's in its purest form that can be on the periodic table of elements. Let's go with neutrons, 26.982. Let's round that up. Let's make that 27. So this is our atomic mass. We don't know what the neutrons are, but we know our mass is 27, and we know our protons are 13. And just to review again, our mass is made up of protons plus neutrons. Therefore, we can say 27 minus 13 is going to equal 14 neutrons. We can put 14 right here. Okay, so we know P equals 14. We know, P equals 13. Sorry for that mistake, guys. P equals 13, and our neutrons equal 14. On our first energy level, we're going to have 2. We know that our electrons, we have to get to, the electrons have to equal 13. So we have 2. And then we're going to have 8 on the second energy level. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I did 2 on the first one. I did 8 on the second. And in order for me to get to 13, I have to find out how many I'm going to have there. So that is going to be 3. Oops. Sorry, guys. Okay, so 2 plus 8 plus 3 is 13. So that means on the third energy level, I'm going to add 1, 2, 3. Do I have 13 electron? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I have 13 electron and I have 13 proton, again, 13 positive, 13 negative, it has a 0 charge. Therefore, it can be an atom of an element on the periodic table because it is in its purest form. Guys, this is all I have today for the Bohr model. I want you to go back and review the notes. If you have any questions, please feel free to email me, come visit me in tutorials. I hope to do these screencastifys often, and I will catch you live right after this presentation. Thanks, guys. Take care. Bye.